Okay, class, welcome back, and today we're going to talk about parabolas, which is the other half of section 9.1. And if you look at your book on page number 639, you'll have 4 of these diagrams here. So I have it opening down and to the right. In your book, it also has it opening upward and to the left. So what I'm going to do is I'm going to explain some of the things. So you have your vertex. So your vertex is the point right here, and the vertex is midpoint between this line called the directrix, okay, which we will label as a D, and the focus, which is an F. And it is equidistant between there. So this distance, which I have highlighted in yellow, is equal to that distance highlighted in yellow, and each of those distances is called P. Okay, and the same thing here. You have this distance is P on the right hand side, and this distance is P, which is halfway between the directrix, which is a line, to the vertex, and then the focus. Okay, so those are the main things. The one other thing that this diagram shows is what's called the axis of symmetry, and the axis of symmetry goes through the vertex and the focus, and it makes your parabola symmetric. So it goes through the vertex and the focus. Okay, so I'm going to go ahead and zoom out now. Okay, so now we are going to talk about the different standard forms. So you have the standard form when it's opening up and down, and the x is squared versus opening right and left where the y is squared. In algebra, we only had that the x's was squared opening up or down, but now we're going to just left and right. So I'm going to draw in some rough sketches of it opening up versus it opening down. Okay. So the vertex is going to be at HK for all of these. HK. H comma K, and over here it's also going to be H comma K. So I'm just going to sketch an opening to the right, then opening to the left. So the vertex is the bottom point, so you have the vertex for all of them, or the top point, or the leftmost point, or the rightmost point. Okay, and the vertex was at H comma K, so if you label those values, H comma K on your axes. Okay, so we know that the direction, if your P value, so you have a P value in your equation, if P is bigger than 0, it opens up. If P is less than 0, it opens down. And likewise, if P is bigger than 0, it opens to the right. And if P is less than 0, it opens down. So your focus is P units by definition from the vertex. So if your vertex is here, you go up P units to get to your focus. So I went up P units, so to get to the vertex, I went up K units. To go to the focus, I go up K plus P. So this coordinate is K plus P. So the coordinates of the focus is over H, that's my X coordinate, and then the Y coordinate, instead of going up K, it went up K plus P. And it works the same over here, except you go up to K, and then since P is negative, that's why it opens downward, you go negative P units. So it's K minus P, but P is negative. So it just works out that this is the focus. For left and right, your focus lies inside your parabola, so you go right P units to your focus. So you went over H plus P more, so H plus P. So your x coordinate is H plus P, and then they're both up K units. It'll be the same over here. So the directrix is a line, and I'm just going to go ahead and do orange for the directrix, and it's P units from the vertex in the other direction. So this would be here, and this distance is P, and this distance is P, the vertex being the midpoint. So to get to your directrix, you go up k to get to your vertex, and you go down p. So it'd be at k minus p. And it's a horizontal line going through the y-axis, so it's y equals k minus p. And over here, your directrix would be out here, and here your directrix would be over here, labeled with a D, and you went over h to get to your vertex, and instead of going h plus p, you go h minus p. So this is h minus p, and it's a vertical line, so it goes to the x-axis at h minus p. The axis of symmetry, which I'll do in green, goes through the vertex and the focus, and for up-down, they both go through x equals h, and for horizontal, they both go through y axis at k, y equals k. So let's go ahead down to the examples. Okay, so here we are at the first example, and you'll either need to flip back and forth or really just understand that the vertex is at h comma k, and then you go p units in either direction to get to the focus and the vertex. Okay, so for this problem, we want to find the vertex, the focus, and the directrix of the parabola. Oops, and then sketch its graph. Okay, so in order to do that, we have to take this equation and put it into standard form. And we notice that the x is squared. So if we look back, we have two columns to choose from. Is it the up-down kind or the right-left kind? Well, for the up-down kind, the x is squared. For the right-left kind, the y is squared. So we have, for our problem, that our x is squared, which means it's going to be an up-down parabola. And we're going to use x minus h squared is 4p y minus k, which means I want the x's on this side and then the y's on the other side. So what I'm going to do is I'm going to keep my x's here, and then I'm going to take my 8y and put it on the other side and my 9 to the other side. And I'm going to have to end up completing the square to write it as a perfect square. So I have x squared minus 2x, and leave some space. I have to subtract 8y to the other side and subtract 9 to the other side. And I'm going to complete the square. So remember, when you complete the square, you take your x and you take half of your minus 2, which is minus 1, and that becomes a perfect square. So minus 1 squared is plus 1. So you take half of minus 2, and it goes here, and then square it, it goes up there. You added 1 here, so you have to add 1 here. And I'm going to simplify minus 8y, and then minus 9 plus 1 is minus 8. So now I have my x minus h squared on the left-hand side done, but the right-hand side has to be simplified, and you do not want a coefficient in front of the y squared, the y term, so I have to pull that out. So I have x minus 1 squared is minus 8 y plus 1. It's plus 1 because minus 8 times plus 1 is a minus 8. Okay, so now that this is in standard form, I can read off that the vertex is 1 comma minus 1 because it's x minus h, so it's y minus a negative 1. So I'm going to go ahead and plot that. So I go 1 minus 1 to get to my vertex. I'm going to label those values as 1 and minus 1. You have your minus 8, which tells you that since when it was up down, p is negative. I know that it opens down, and 4p equals minus 8, because they're in the same position, so it tells me p is minus 2, and that's a very important number. So I know it's going to open downward. I'm just going to sketch my downward facing parabola, because we're going to sketch here. P is minus 2. I know my focus lies inside, so I'm going to go down 2 units, because the distance from the vertex to the focus is 2 units. So that's at minus 3. And then I'm going to go from my vertex up 2 units to get to the directrix. And the directrix is a line, which you should use with a ruler, labeled as D. So you have the value D, V, and F labeled. Okay, so now we need to write the coordinates, because we had to identify the vertex, the focus, and the directrix. So the focus, we drew it in because we knew the vertex, and we knew it would go P unit down, since it opened down. We knew P was negative, so you go down. So the coordinates are 1 comma minus 3, just reading those off. The directrix is a line. It goes through the y-axis, so it's y equals, goes through the y-axis at 1, so it's y equals 1. So we found the 3 things that we're asked to find. And we did our sketch. And this is at most of what we're going to do for our sketch. We're going to have the important values labeled. We're going to have the directrix, which is a line labeled with a D. You're going to have a curvy parabola with arrows on both ends with the vertex labeled with a V and the coordinates on the axes marked and the focus marked with an F with those values labeled. Okay, let's go down to example 2. Okay, so example 2 asks us to find the standard form of the equation with its vertex at minus 1, 2. So I'm going to plot that, minus 1, 2 for its vertex. And its at focus is at minus 1, 0. So the focus is right here. Okay, so you have to determine, is this going to be an up, down, or a left, right parabola? Well, you know that the focus lies on the inside. However you draw your parabola, your focus is on the inside of your parabola. Okay, so the focus is always on the inside. So the only way you could draw this parabola is to be a downward facing parabola. Now we're not asked to sketch it. The only reason we have the sketch here is to help us out. So I know it's an up-down, specifically a downward-facing parabola. So I know that it's x minus h squared is 4p times quantity of y minus k. I know we're going to use this one versus the other one in the right-hand column because it is an up-down. So I have my h and my k, because that's my vertex, h comma k. So I can plug those in. X minus a negative 1 becomes x plus 1 equals 4p y minus 2. Now I don't know what p is, but I can plug a value in for p. We can read off what that is. Okay, so what is my p value that I need to plug in here? My p. Remember, p is the distance from the vertex to the focus, and also from the vertex to the directrix. So that is p. Okay, so p is this much here, which is 2. But since I went from the vertex to the focus down to, p is a negative 2, so that is a negative 2. Okay, so remember, from the vertex to the focus, so start at the vertex. If you go down to get to the focus, it's negative 2. If you went left, it would be negative 2. Up and to the right would be a positive 2. So you just simplify x plus 1 squared. 4 times negative 2 is negative 8, y minus 2. And this would be standard form. So for standard form, you just plug in h, p, and k values. Okay, so we had to find the standard form, and that's all that we were asked to do. So that is the end of this video. So what you need to do next is look in your book on page 639. Oops, sorry about that, pushed the button. And read through that and examples in the rest of your book for the rest of section 9.1, and then go ahead and start your homework assignment. Have a good night, and I hope you had a great Christmas